Okay, these are for numbers 13 through 16 on the related rates worksheet. Joey flies a kite at a height of 700 feet, the wind carrying the kite horizontally at a rate of 20 feet per second. How fast must he let the string out when the kite is 1,100 feet away from him? So it's very similar to the last for the airplane problem, except we're looking for DSDT, and we've got DXDT, so let's write down what we've got. So I drew a sketch over here. Here's Joey down here. Here's the string. This is the horizontal position of the kite that's changing, but it's always at 700 feet high. Okay, so what information do we have? Well, we've got the 700 feet, so that stays the same. And it's moving horizontally at a rate, the wind's blowing at 20 feet per second, so that's DXDT. So DXDT equals 20, and that's going to be feet per second. Okay, and how fast must he let the string out? So we're looking for DSDT when the kite is 1,100 feet away from him, so when S is 1,100 feet. We're looking for DSDT. So again, we have our Pythagorean relationship. A squared plus B squared equals C squared. These things are changing. This is always the same, so this is what stays in here. But these are changing because the kite's moving this way and the string's going out. So the string's going out like this as the kite moves this way. So these are changing. So those we have to use variables, but this is always the same. So it's a constant. So we know that 700 squared plus x squared equals s squared. If we take the derivative, it's very similar to the airplane problem. 2x dx dt, because we're taking the derivative with respect to time, implicitly equals 2s, that's the power rule. And then ds dt, implicit differentiation with the chain rule. Okay? And then we're looking for ds dt, so I'll divide both sides by 2s, so I have 2x all over 2s times dx dt equals ds dt, and that cancels, so we can say actually that ds dt, so over I guess I can write ds dt equals x over s times dx dt. So there's your ds dt you're looking for, so we just put our data in. And dx dt was going to be 20, so this is going to be 20 feet per second. And the s was going to be 1,100 feet. And the x will be in feet, but we don't know what that is. So again, we're going to have to use another right triangle because, again, these numbers are always in this Pythagorean relationship. So we'll draw another triangle over here. Sketch it out real fast. This is 700. This is 1,100. And we're looking for x. So we don't have the x. So I got some big numbers here. 700 squared plus x squared equals 1,100 squared. Let's see if we can do this without a calculator. So 7 times 7 is 49. And then if I square 2 zeros, I get 4 zeros. Plus x squared. Now 11 squared is 121. I know that. And if I square 2 zeros, I get 4 zeros again. Okay. So x squared equals, I'm going to have to subtract 4 zeros and the 49. Don't like that. Okay, so what do we got here? Well, we got my 4 zeros. And then if I subtract, I make that 11, borrow 1, so that's going to be 9 from 11 is 2. And then that's going to be 1 and 4 from, that's 72. And then I got the 4 zeros. 4. Let me go double check that. That's 11, carry 1, 12, so it checks out. So x equals the square root of this. Now, if you take the square root of 4 zeros, you get 2 zeros, so that's 100, and the square root of, well, that's going to be 2 zeros is 100, so I've got 100 times 100, so the square root of 100 times 100 is 100, so I can take that out. So x equals 100 times the square root of 72, but 72's got a perfect square factor. That's 36 times 2. That's equal to 100 times the square root of 36 times 2, and the square root of 36 is 6. So that's going to equal x equals 6 times 100 is 600 times the square root of 2. That isn't too bad. So that goes over here. 600 times the square root of 2, and that's going to be my dx dt, or ds dt, excuse me. And I can get rid of some of these zeros. Gosh, I got all kinds of things that I cancel here, so let's get rid of some of these zeros. So I have that equals 6 over 11 square root of 2 times 20 feet per second. And that's going to equal, and then I guess nothing to cancel there, so I guess I'm just going to say 120 times the square root of 2 over 11, and that's going to be feet per second. And that's my ds dt. And you can leave it in radical form. Okay? So there you go. So I hope you could see all that stuff we did. Move it so you can see it in case I got carried away here. You can see the work I did over there with the radical, and then you can see putting it back in. So there's some arithmetic to be involved, but don't be afraid to do arithmetic. You need to know how to do that stuff. It's not too hard. It can all be done.